How do you do? How do you do? How do you do? I do fine because we are going to start going over the June 2017 Algebra 2 Common Core Examination. This is the first video, problems 1 through 8. Let us get us startidious. Let's just get started. Boom. Part 1, answer all 24 questions in this part. Each correct answer will receive 2 credits. No partial credit will be allowed. This is multiple choice. It's either 100% right or 100% wrong. Utilize the information provided for each question to determine your answer. Note that diagrams are not necessarily drawn to scale. For each statement or question, choose the word or expression that, of those given, best completes the statement or answers the question. Record your answers on a separate sheet, answer sheet. Bang, done, good. You know what you're doing. This isn't your first rodeo. Let's get started. The graph of the function p of x is sketched below. Which equation could represent p of x? What I know about graphs and mathematics is the X-Intercepts, also known as the zeros or solutions, okay, are important because this crosses at 2, at 3, and at -3. So I have 3 answers, -3, 2, and 3. If I were to reverse T-bone and Boutte cheek these things, meaning if I were to go backwards, instead of factoring and solving, I have my answer. I've already solved. I want to put them back into factors. This would have to come from x plus 3. This would have to come from x minus 2. This would have to come from x minus 3. And if I were to multiply these things together, if I FOIL this and this, that is a DOPS, a difference of perfect squares. That would end up giving me x squared minus 9. And then this thing just comes along for the ride, x minus 2. Is this an answer? It is. You could FOIL those together if you wanted. But I look at this, and I see that right here. Bam. How could I do this in the calculator if I could not do this algebraically? I could graph this and see if it's the graph. It would be. If it wasn't, I would graph this in Y1 and check to see if the graph matches what they gave us, and so forth. Yes, you could do this in the calculator, but that's how you do it algebraically. Ooh, an exponential question. What is the solution to 8 times 2 raised to the sum of x plus 3 equals 48? Yeah. What you could do, if you were crazy enough, these are all x values. I could take 0, put it in for x here, and see if it equals 48. If it doesn't, I could take this, put it in for my x, and so forth. I could try them one at a time. All right? I'm going to solve this algebraically. Yeah. I've got 8 times 2 to the x plus 3 equals 48. I know in order to bring a variable down for my exponent, I've got to use log or natural log. And I want to get the base and the exponent alone. So I'm going to get rid of this 8. All right? I've got 2 to the x plus 3 equals 6. Now I've got to take the, I like to use ln. I could use log, but all my possible solutions have ln in them. And you know me, if I write log, that's 3 letters. If I write ln, that's 2, and it's a lot faster to write. I just like to do things with a quick and efficient manner. Okay, I'm taking the natural log of both sides. When I take the natural log, this can come down and be a lead term. So I have x plus 3 times the ln of 2 equals the ln of 6. All right, now I've got to solve for this x and start stripping things away using opposite math. Divide by the ln of 2, bang, bang. Divide by the ln of 2. All right, I'm going to continue this over here. I've got x plus 3 equals, okay, the ln of 6 over the ln of 2. I can see exactly which answer it's going to be, but let's finish this problem off. Let's subtract 3 from both sides. So x equals the ln of 6 over the ln of 2 minus 3. Choice 1. Brilliant. Great. Good even. All right, here's a miscellaneous type problem. And this is kind of an understanding about logic when it comes to collecting information, okay? Number 3 says, cheap and fast gas station is conducting a consumer satisfaction survey. Which method of collecting data would most likely lead to a biased sample? Which method of collecting data would lead to a biased sample? That means the people you interview are going to be swayed one way or another. It's not going to be completely random. Like if I asked only Buffalo Bills fans who their favorite team in the AFC East was, they would probably all say Buffalo. No one would ever say New England. But if I randomly interviewed people all over this country, not just in Buffalo or in the upstate New York area, who your favorite football team in the NFC East is, it would vary. The people who live in Buffalo would be biased to the Buffalo Bills because they're favoring them. So which one of these options would likely lead to having bias behind it, which means would be kind of like a little bit on the unfair side? Okay. Number 1, interviewing every 5th customer to come into the gas station. That's not biased at all. That's randomly interviewing people. Okay, whether you don't even know, and that's as they come in, so you don't even know if they have a good experience or bad experience yet. They are just walking in. That's good. All right, 2, interviewing customers chosen at random by a computer at checkout. Sure, before they even check out, you're not just interviewing people who got gas. You're not just interviewing people who came in to buy the soda or whatever. You're randomly choosing someone. Doesn't matter their age, gender, race, whatever. It's good. Interviewing customers who call an 800 number posted on the receipt. You have no control over that. That's, I'm going to put a little question mark there. That can possibly be it. Interviewing every customer who comes into the station on a day of the week chosen at random out of a hat. Okay, 1, 2, and 3 are completely random. You cannot control the 5th person. You cannot control who the computer picks, and you cannot control who comes into the gas station. Why would number 3 be the correct answer? And it is. The people who call the 800 number, let me ask you something. If you have a really good experience, do you call the 800 number? You do not. If something went wrong and you want to speak to someone, those are the people who typically call the 1-800 number. All right. People who call the 1-800 number have an opinion already formulated in their mind. Okay. These are people who are going to share what their thought process is, meaning they go into the station, they come out, and either it went really well, and that's already in their head before they call, or it went really bad, which is the majority of the calls you'll get. Does that make sense? I'm only going to call this one. If I go to McDonald's and I go in and I get everything, I get my burger, whatever, fries, and leave, I'm not going to call an 800 number. That's what I get. Okay, whatever. But if I go there, it takes 25 minutes. The burger was cold. The fries were rock hard. I'm going to call it 1-800 number and be like, hey, what the heck, man? So I think number 3, in fact, I know number 3 is the right answer because that would have the most biased. Number 4. Oh, back to algebra. And I. I love me some I. Now, let's just get this under wraps here. We've got to FOIL this. The expression 6xi cubed times times negative 4xi plus 5 is equivalent to which one? Yes, there's a way to do this in the calculator. I can put this into y1. And then I can take all these and put them into y2. If the graphs are the same, it's the answer. If the graph is not the same, I would try putting this into y2. How can I do that? You only have one variable, x. I is not a variable. I is a number. It is an imaginary number. Not only is it a number, it is above the decimal point in the calculator. So if I wanted to graph something with an I, okay, second decimal point in blue, there it is. Let's see if you can graph You know, I've never really tried to graph on this calculator with an I. Let's see what happens if I try and graph this. 2x minus 5i. 2x minus 5. Let's see if we can even graph that, because this axis might be the real set of numbers. See graph. Yeah, that's weird. Let's go to zoom fit. Let's go to standard first. Standard 10 by 10. I see nothing. Let's go to zoom fit. Maybe it's just way off the charts here, which I doubt. Zoom fit. That's the one we want. Yeah, let's move this. Bam. Yeah, you can't. Oh, look it. So you can't do that in a calculator. Boo-hoo, you've actually got to FOIL or distribute. I'm going to multiply, okay, 6 xi cubed times negative 4 xi. 6 times negative 4 is negative 24. X times x is x squared. I cubed times I is I to the 4th. All right? Now, I've got to multiply my 6xi cubed times 5. 6 times 5 is 30. And this will stay the same. Xi cubed. All right. All right. All right. Well, first off, okay, we need to try and simplify this. And there are some rules. Okay, the first thing is I squared is negative 1. All right? That's a big one to know. But also you should know a few more things. I to the 0 power is 1. I to the first power is just I. Anything to the first power is itself. Anything to the power of 0 is 1. And I cubed is negative I. These are the 4 major rules that I squared is the biggest one to know. And if we want, we can kind of break these up accordingly. First thing you should know is these cycle. I to the 4th is the same thing here. I to the 5th, I to the 6th, I to the 7th, and it cycles. It goes I to the 8th, I to the 9th, I to the 10th, and so forth, I to the 11th. It just keeps on going, all right? So if you have I to the 4th or I to the 8th, that's the same thing as I to the 0, which is 1. Okay, if you have I to the 6th or I to the 10th, that's the same thing as I squared, which is negative 1. All right? That's one way you can do it. All right? So we know that I to the 4th is 1. So I've got negative 24 times x squared times 1 plus 30x I cubed is negative I times negative I. All right, and let's just finish this off. So 1 times anything is itself, negative 24x squared. A positive times a negative will be negative 30xi. And that's your answer. Okay, that is right here, choice 2. Now, there is a second way we can do this. If you are good, I'm going to erase this for 1 second here. You can, if you wanted to, you can say this is negative 24x squared. You can break this up. I squared times I squared gives you I to the 4th, doesn't it? If I multiply those two, isn't I squared negative 1? So that's like saying negative 1 times negative 1. What's negative 1 times negative 1? A positive 1. So that is what this would equal to. So it would be 1 times negative 24 times x squared, which would be negative 24x squared still. Okay. This, we have 30x. My I to the 3rd can be I squared times I. Yep, I'll be okay. I would just stay the same. I squared is negative 1. So that's negative I times 30x. And you would still get minus 30xi. So you can kind of do it that way. If you get stuck remembering it, you can always break it down. But I think that first way is by far the easiest way, just to know your terms. Know that if you divide any exponent by 4, whatever the remainder is that new exponent for I. Let me give you one example of that. I hate to do this a million, but in order for you to better understand, because what if you had I to the 34th power and you needed to cycle through here? If I take 34 and divide it by 4, that goes in 8 times the remainder of 2. This remainder is the equivalent exponent, which means I to the 34th power would eventually be somewhere in this long list. All right? And there you go. You got it. Number 5, cinco, if you will. All right? If f of x equals 3 times the absolute value of x minus 1, and g of x is 0.03x cubed minus x plus 1, an approximate solution for the equation f of x equals g of x is, let me explain something to you. Whenever they give you 2 equations with 1 variable in it, and they want to know the answer, graph them both, and it's where they intersect. Put that in y1, okay? Put this in y2 and check your intersection. It is an approximate, which means I am looking at all of these answers. They are 2 decimal places. I am probably going to have to round 2 places to the hundredths, okay? So let's go ahead and do this. Now, keep in mind, an approximate solution for the equation f of x equals g of x is, I don't like this already because I see 11.29 here, and I see 11.29 and 32.87, but it's in parentheses like it's a coordinate instead of listing possible intersection points. You can have 1, 2, or even 3 points of intersection here. Because a cubic goes like this. I should just do this. And it goes, yeah, and that's an absolute value. I can have up to 3 intersection points. Let's see. Let's take a look at what we got here. We won't know until we put it in the calculator. So what I'm going to do is the following. Put this here. View detached LCD. Right down here. Turn this bad boy on. Go to y equals. Clear this imaginary poop out. And I say 3. If I go to math and move over to number, ABS is for absolute value here, okay? Of x, I pop out and subtract 1. All over, I'm going to put this in here. 0.03x cubed, pop out there, minus x plus 1. And if I graph this, okay, there's the absolute value. Okay, it looks like, oh my goodness gracious. Now, 2 spots at intersects. We'll see if those are there at all. And then it looks like this is going to go up and get steeper. And this is going to cross. I mean, it's eventually going to cross as well over here somewhere. If this were to continue. Let me change. Okay, let me find these 2 intersection points first. Second, calc. Intersect number 5. Bang. Put my little bug dude closer to the intersection point. Hit enter 3 times. 1, 2, 3. Negative 0.985. That's one of my answers. I'll just put this right here. Okay. Now let's do the next one. I'm going to intersect this point right here. So second, calculate intersection. Bam. And I go here, go down to this little bugger right here. Enter, enter, enter. 0.5009. Here, I'm going to list that here. So now, let's just for poops and giggles, let's see what this is. So I'm going to change my window. I'm going to go higher on the y-axis. Let's go to 30. Graph. There, look at that. Bang! Oh my God, it's good. It is going to intersect over here. I got to go farther on the x-axis as well. So let me go to my window. Let me go to, no, let's go to 20 on the x-axis. And let's go to 40 on the y. Let's make sure it goes high enough. Bang, there it is. Look at that, what they try and do there. Second, calculate, intersect. Enter. Bam, 3 times. 1, 2, 3. 11.29 is what that'll round out to be. So I go here. I go here. And I go here. Okay, we have 3 possible points of intersection. All right, right. All right. Boom. So 1.96. That is not here. That is not here. And that is not here. 11.29. Ding, 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 ding. If I round that, I get 11.29. But like, let's look at this one here. All right. Here's what I don't like about this problem. This is not a coordinate. This tells, okay, this is an x value, which would be right here rounded. This is also an x value. Look at what, if I wanted you to write this coordinate of intersection right here, you would have negative 0.99, comma, 1.96. That would be a coordinate. This is not a coordinate. This is listing all my solutions. This is not an x value. It's a y value. Same thing right here, 32.87. That's not a y value. That's another x. I don't like how they did that at all. That's dirty. Let me tell you what. Whoever wrote this problem is a major a-hole. That is dirty. I hate that with a passion. What they should have done is they should have put the curly braces here like this when you list all of them. Okay, they're going to make the argument that, oh, approximate solution, these should all be answers then. No, that's just trying to screw with somebody. That's trying to make sure that no one gets an absolute 100% perfect score in the test. And I have no respect for that whatsoever. But hey, what are you going to do? In class, I never say this. Okay, I never do that. I would either list them like this, okay, or I would, even in calculus, or you list them like this. In calculus, when you have an interval, notate, you know, like when from x is 2 to when x is like 13 or whatever, it's listed like that as an interval. Okay? So this is very bad preparation for future math whatsoever. Bang, bang. The answer is choice 2. Drives me nuts. All right, so after a pain in the tuchus problem, we now have a nice, easy problem. Given the parent function, p of x, which is cosine of x, okay, so this is what we're starting with, which phrase best describes the transformation to obtain this? So how do we get from cosine of x to this thing right here? Oh, all you got to do is know your rules for movements. Okay, and they're going to tell you, assume that a and b are both positive integers. So you're subtracting, b is you're subtracting a positive number. You're not subtracting a negative, so it's not going to be this. Okay, this they're saying it's not this. Okay, so minus b is what it is, minus b. Your rules for movements of graphs go as follows. The outside would represent your up and your down. If you're adding, you're moving up. If you're subtracting, you're moving down. So we are moving down b units. Whatever b is. If b was a 6, we are moving down 6. If b was 3, we're moving down 3. Okay? Now, when we are inside parentheses, everything in parentheses kind of goes opposites. We normally think right is positive on the x-axis and left is negative, but they're flipped. Okay, if I'm moving right, it would be a negative sign. If I'm moving left, it would be a positive sign. So we're moving left a units. Look at me write cursive like ln. Okay, if a was a 2, we'd be moving left 2. Okay, so we are ultimately moving left A, down B. Left A, down B. There's your answer. You just have to know the rules. You don't even have to apply mathematical calculations to them. Just know your rules. Nice, easy problem. Number 7, the solution to the equation 4x squared plus 98 equals 0. You can use your calculator and put a plus or a minus 7 in for x and see if it works. If it does, that's your answer. Okay, I know for a fact that I'm going to have an imaginary answer. How do I know? If I have a positive 98, that means this right here should equal negative 98. Okay, I can't get a negative number if I'm squaring something ever. So I have to have imaginary. So right now I know it can't be 1 or 3. Okay, did you have to know that? No, you didn't have to know that. Okay, we're going to do this algebraically. Could you have plugged in all of these? Yes, you can plug in, let's say, this 7i in for your x, and if it works, it's the answer. If it doesn't, that's not the answer. You can calculate that in the calculator, and let's not forget, above the decimal point in blue is your imaginary number I. All right, so let's get going. I'm going to use the quadratic formula. Yep, I'll be okay. That's not an exponent, that's just another term. All over 2a. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Here's the problem. I have 4x squared. I have plus 98 equals 0. I have plus 0 x's. Okay, you need to know that because your a is 4, your b is 0, and your c is 98. All right, so I'm going to negate b, which happens to be 0, plus or minus the square root of b, which happens to be 0, squared minus 4 times a, which is 4, times c, which is 98. Wow. All over 2 times a. Let's clean this up, shall we? 0 goes bye-bye, so I have plus or minus. Okay, let's figure out, oh man, I haven't used my highlighter at all today yet. Let's figure out what this is underneath a radical, all right? Now, I know it's going to be radical something. Let's just put that highlighted value in the calculator. On. There it is. Second, quit, clear. I'm going to take 0 squared. Okay, 0 squared minus 4 times 98. And hit enter. It's negative 1568. Negative 1568 all over 2 times a, which is 4. Yeah, I didn't put that 4 in right there. I just left it in a. Okay, you might think to yourself, man, that's going to be real difficult to figure out what goes into it. One of the factors of 1568 is going to be 2. Either it's going to go unevenly, or you're going to have a factor of 2. So I'm going to do this. What is the square root of 1568? That is not even. So let's take 1568 divided by 2. 784. What's the square root of 784? Oh, 28. So hear me out here for a second. I can say that's plus or minus the square root of. I just said if I divide 1568 by 2, I get 784. 784 times 2 would give you 1568. So I'm going to do that. Negative 768 and 2. If I multiply those two together, I get my 15. Oh, that's a 4. Okay, 764. No, that looks like garbage. Oh. 764 times radical 2. Okay, if I multiply those two together, I get that. All over 8. And we know the square root of 784 is 28. Again, it's a 6, it's an 8, 784. So the negative comes out and becomes an I. The square root of 784 is 28. And then I still have my radical 2 all over 8. Ooh, okay. Well, I can reduce this. 4 goes into here 2 times, and 4 goes into here 7 times. So it's plus or minus 7I radical 2 all over 2. Oh my goodness gracious. There we go. A little bit of work to it, but not impossible. And if you couldn't do that, just plug them in. Okay, you're solving for x. Plug them in for your x. You're good to go. Easy. 8 is easy. Which equation is represented by the graph shown below? Okay, well, first thing I know is they are all cosine. Okay, so that's not going to help me. And cosine is indeed the cup. Boom. Okay, the amplitude. Okay, here's the middle. From the middle, I go up a half and down a half. So my amplitude is going to be 1/2, 0.5, which also equals 1 over 2. Here's my amplitude. This one happens to be 1. It's not 1, it's not 2. So now it's between either choice 1 or choice 3. One curve starts here at 0 and ends at 180. That's what pi is. It's 180 degrees. All right. So I need to figure out my frequency. Is my frequency 1 or is my frequency 2? Well, frequency is 360 divided by period. Or you could say it's 2 pi divided by the period. Okay? If I were going by degrees, I would use this one. I would be 360 divided by 180. In which case, that would be 2. If I was going to use radians, I would use pi. So I'd take 2 pi divided by pi, and I would still get 2. So either one is 2. This is not 2. Bang. Well, that is 2. There you go. And that's the answer. That was a nice, easy one. Again, you got to know your rules, okay? Know your rules. We will stop here. I will see you for the next video, which will be 9 through 16. I'm excited. See you later.